Hello everyone, good day. In this video, I want to explain domain and range of functions. Domain and range of functions. I will define with some examples. Okay. Um, if we are given, let's say you are given a function f of x. For this function, let us say the function is defined by f that takes set A to set B, right? The domain of f is written as dom f is the set of some x in A, that is in this domain, okay, such that f of x is defined. So in short, they are the set of members of A for which f of x does not vanish or for which f of x is defined. Okay, and then we define the range of f as the set of members of B, okay, such that for every x in A, f of x is equal to y. Okay, so they are the set of members of B that have preimage in A. If you take function of x, you get a member of B. The set of all members of B that are mapped, that have preimage in A, are called the range of f. All right, let me give you this example. For example, let us look at this function f of x that is defined to be, say, square root of x plus 2. Look at this function. This function would not be defined for x less than 0 in the real sense, because if x is less than 0, that is if x is negative, you're going to get a complex number. Okay, so this function is only defined for x greater than 0 or equal to 0. If you have square root of 0 here, then you get f of x will be 2, or if x is greater than 0, you get a positive real number. So you can only take square root of 0 or other positive numbers in the real sense. So it means that the domain of this function, the domain f, is going to be all members of R, okay, that is all x in the real number, for which x must be greater than 0. That will be the domain of this function. And then the range of this function, they are the set of values you get when you put each of these x equal to 0 in this function, and the list of them that you can pick is 0. Okay, so when you put 0, you're going to get a 2, and 2 is going to be the minimum. If you put, maybe you put 1 now, what you get to be a little higher than 2. So you get some y in the set of real number such that your y is greater than or equal to 2. All right, so that is the range and domain of this particular function. Look at this other example. If we are to find the domain and range of this function, say f of x equal to the square root of x squared minus 7x plus 10. Okay, for this function, just like I explained for the square root here, what you have under the square root must be positive or 0. Okay, at least minimum of 0. So that is x squared minus 7x plus 10 must be greater than or equal to 0. And this is only possible, it's a quadratic function. This function can be factorized. If you factorize this function, you get x minus 5 and then x minus 2 greater than or equal to 0, and this can only be greater than or equal to 0 if the two of them are both negative. That is, if x minus 5 is less than 0 and x minus 2 is less than 0, or if the two of them are actually greater than 0. That is, if they are both positive. So those are the two cases. That is, if we have x minus 5 less than 0, less or equal to 0, or x minus 2 less or equal to 0, and if we have x minus 5 greater than or equal to 0, or x minus 2 greater than or equal to 0. These are the two conditions that can satisfy this equation. So if you check, you see that if you solve each of them, what you get here is x less than or equal to 5, or x less or equal to 2. And then for this other part, you get x is greater or equal to 5, or x is greater than or equal to 2. So for each of the two parts, it is sufficient for us to pick x is less or equal to 2. And for this other part, it is sufficient to pick x is greater than or equal to 5. Okay, that covers the range. That covers the range. So it means that this range is from negative infinity up to 2. Okay, and then plus, that is union from 5 or to positive infinity. This will be the domain of this function. Okay, that is the domain of this function, for which this function f of x will be defined. That is, what you have under the square root must not be 0. Then you must pick values from minus infinity to 2, or plus values from 5 to positive infinity. Example, look at if you have f of x equal 2x plus 1 divided by x minus 1. Look at this function. This is a rational function, a fraction. Okay, now for this function, it will be valid for all values except for when x is 1. If x is 1, you get 2x plus 1 divided by 1 minus 1, and that is 2x plus 1 divided by 0. So the function will be undefined for when x equal to 1. So for all the values you're going to pick, you're going to try to avoid using 1, but any other number will be valid, even 0, negative numbers, positive numbers, so will be valid in this case. So it means that the domain of this function is going to be the set of all x, okay, maybe in the real number, and these numbers in R, they take values from just before you get to negative infinity and before you get to 1. That is this open interval. Then and then from this side too, from this open interval 1 and infinity. I hope you understand that these are open intervals, meaning that you cannot get to negative infinity here and you will not get to 1. You will not get to 1 here and you will not get to positive infinity in this regard too. So we have excluded 1, okay? Or you can write the domain to be domain of f, the same domain of f as the set of all r minus 1, okay? So excluding 1, it is still the same thing that we have written. And then the range of this function f is the set of all y in R. It is the set of all y in R except infinity. All right, this is the domain and range of trigonometric functions. I'm going to provide another video where I will give the domain and the range of other trigonometric and hyperbolic function. That is, I will give the domain and range of inverse trig function and the hyperbolic function and its inverses. Thank you for watching. For more of these videos, you can click like and subscribe to my channel. Thank you.